Question number 1. How many grams of concentrated nitric acid solution is used to prepare 250 ml of 2 molar nitric acid, and the concentrated acid is 70 percentage of nitric acid is pure, which means remaining 30 percentage is water to give 100 grams of this nitric acid sample. Okay, now how much of the sample I have to take? That's the question. They are given molarity, they are given the volume, correct? So we go for now molarity formula. Molarity M is equal to amount of the nitric acid divided by the molecular mass into 1000 divided by volume in terms ml wise. We know this formula, correct? Substitute and get this here. What is the weight of this nitric acid, pure nitric acid required? So molarity is given 2 molar. So W is unknown. Molar mass of nitric acid HNO3, atomic mass of hydrogen is 0.1 and nitrogen is 14. That of oxygen is atomic mass is 16 into 3 times, so becomes 48. So it is equal to 63. Okay, so 63 grams per mole into 1000 divided by volume is given in the question 250 ml. So divided by 250 ml. Therefore, this W is equal to comes to be 31.5 grams of nitric acid. Remember, student, this is a pure nitric acid. Okay. Suppose I take 100 grams of this nitric acid sample. In that, pure nitric acid only 70 grams. So 90 grams of pure nitric acid is present. I want 31.5 grams of pure nitric acid. Therefore, how much of that sample I have to take now? So if we cross multiply, this is equal to 100 into 31.5 divided by 70. This comes to be approximately equal to 45 grams. Okay. So therefore, answer is option number 4. D is the answer. Clear, students? Right? Question number 2. 1 molar 2.5 liter of sodium hydroxide is mixed with 0.5 molar 3 liter sodium hydroxide. Then find out the molarity of the resulting solution. They are mixing two sodium hydroxide solutions. They will find out the molarity of the final solution. So therefore, molarity of the final solution mixture, we have the formula here. Remember, V1 M1 plus V2 M2 divided by the total volume V1 plus V2. Just simply substitute here 1 into 2.5 plus the second one 0.5 into 3 divided by the total volume 2.5 liters plus 3 liters, correct, which is equal to this is a 2.5 plus this is equal to 1.5 divided by this is a 5.5. This comes to be 4 divided by 5.5, which is equal to 0.7 comes approximately. Okay, right? So answer is option number C, correct? Question number 4. 3. 5% solution of cane sugar with a molecular weight 345 given isotonic with 1% of substance of X. Molar weight of the X is. Isotonic solution means their osmotic pressure should be same. Osmotic pressure given by the formula CRT, where C is the molarity of that solution, correct? This is the molarity, right? So R and T are constant there, which means concentration of the first solution should be equal to concentration of the second solution. First solution given is the cane sugar, and the second is unknown. Let it be X. Molarity, right? So molarity of the first solution should be equal to molarity of the second solution, right? How to calculate molarity? Molarity is equal to number of moles of the solute divided by volume in terms of liters. This side also number of moles of the solute divided by volume in terms of liter. Even Now they give in terms of percentage. Why? Percentage always out of 100 ml. So therefore, these volumes are same both the sides. How to calculate number of moles? Number of moles equal to given mass divided by the molar mass for the first one is equal to given mass divided by the molar mass of the second one. Okay. So they are given 5 percentage. 5% means 5 grams divided by molar mass of cane sugar given 342 is equal to W2. 1% it means 1 gram divided by the molar mass is unknown. Let it be M2. Then when you calculate M2 is equal to, so this is a 342 divided by 5, that is approximately equal to 68, comes 68.4 exactly. So the answer is option number C. Okay, fine. Question number 4. Which of the following statement about composition of the vapor pressure over an ideal gas of 1 is to 1 molar mixture of benzene and toluene? Okay, this is in the liquid form now. 1 mole is to 1 mole, we can assume. Assume that temperature is constant at 25 degrees centigrade. Vapor pressure data given at 25 degrees centigrade, vapor pressure of benzene is 12.8 kilopascals and that of toluene is 3.85. Vapor pressure is more. When the vapor pressure is more in the vapor state, okay, the mole fraction of benzene is more. Mole fraction of benzene is more. Mole fraction of benzene will be more. Understood? When you compare these two vapor pressures, vapor pressure benzene is more. When the vapor pressure benzene is more amount of benzene is present in the vapor state, which means mole fraction of benzene should be also be more in the case of vapor state. Or we also can calculate, okay, you calculate the total vapor pressure, then calculate the partial vapor pressure, then calculate mole fraction of the components in the vapor state only. Okay, so we can directly go for here. Answer is the first one. The vapor will contain higher percentage of benzene. Okay, right? Question number 5. An aqueous solution of 1 molar in 1 molar in Ki, which will change or cause the vapor pressure of solution to increase. Remember student, as the concentration of the solution goes on increases, okay, its vapor pressure goes on decreases, which means if I dilute the solution, its vapor pressure goes on increases because more and more solvent will try to vaporize, give the more pressure, right? So what should be the answer? We should not dissolve these electrolytes. Okay, so add more and more water, dilute it. So therefore, water will vaporize easily, giving the more vapor pressure. Right? So D is the answer. Question number 6. Vapor pressure of two liquids P and Q are given 80 and 60 torr respectively. Total vapor pressure we need to calculate by mixing 3 moles and 2 moles. So total number of moles are 5 moles. Okay, would be, so how to calculate total pressure? Total pressure is equal to partial pressure of the component A plus partial pressure of the component number B. So here two liquids are there. So component is P and component B is, let it be, Q. Okay, how to calculate partial pressure? Partial pressure is equal to P naught of A into XA, correct? Mole fraction. Vapor pressure, the pure state into its mole fraction. So this side also P naught B into XB, correct, is equal to, for the first component, vapor pressure is 80 into mole fraction, total number of moles are 5, fraction of that one for Q, how many moles are there? 3 moles are there, correct, plus for the second one, vapor pressure pure component is a 60 torr into mole fraction of the second one. Total number of moles are 5. Take the fraction. Out of that, 2 moles of Q. Correct? Therefore, when you calculate this one, you'll get this answer is equal to 72 torr. Okay? The answer is option number E. Right? Question number 7. Which one of the following electrolytes at the same value of the Van 't Hoff factor I as that of the aluminum sulfate if all are 100% ionized. What is Vanta factor? Vanta factor is equal to number of particles that are dissociated, or number of particles after dissociation divided by number of particles before dissociation. Okay, before dissociation will take 1 mole of the substance. Okay, so you'll calculate the total number of ions produced. So first one produces 3 moles of potassium. These are coordinate compound. Then remaining the FeCN6 total charge is equal to -3. Correct. So how many ions altogether? Altogether 3 plus 1, 4 ions are there. Aluminum nitrate will dissociate to give aluminum plus 3, and nitrate is a NO3 minus. Correct. To balance it, 3 here. So altogether how many moles are there? 4 moles. 1 plus 3, 4 ions are there. This one, 4 potassium plus FeCN6 total charge B. Positive charges 4, so negative charges be 4. So altogether ions are 5 ions are present. Then potassium sulfate will give 2 potassium plus sulfate SO4 2 minus. So total number ions are is equal to 3 ions here. We will take aluminium sulfate. 1 mole of aluminium sulfate if I take given in the question, this will dissociate to give aluminium plus 3 and sulfate SO4 2 minus. To balance the charges, aluminium is 2 number, sulfate is 3 number, total charges are plus 6 and minus 6. So how many ions are there? 5 ions are there. So which one is matching? So option number C is matching, right? Question number 8. Of the following 0.1 molar aqueous solutions, which one will exhibit the largest depression of the freezing point? Depression of the freezing point, if I include the Vanta factor, it is I into Kf into molality. Molality is same. Kf is also same because we'll be assuming the same solvent. Water is the solvent. Therefore, Kf is directly proportional to the I. Vanta factor I, number of particles. So we'll calculate number of particles in each and every case. More the number of particles, more is the depression, the freezing point. So potassium plus chloride, number ions are equal to 2 ions. This is the glucose. Glucose will not dissociate. This will remain as the C6H12O6 that dissolved from aqueous because of hydrogen bonding, not because of dissociation. Aluminum sulfate just now calculated previously. 2 aluminum plus 3 and 4 and 3 times SO4 2 minus. Therefore, total ions are 5 ions. Potassium sulfate 2 potassium ions and sulfate ions are SO4 2 minus, therefore altogether 3 ions are there. So which one gives the maximum number of ions? C, right? So third one is the answer. Question number 9. zero point 0.1 molar solution of glucose, zero point 0.1 molar solution of urea are placed on two sides of the semi-permeable membrane to equalize. Okay, if there is a vessel, if there is a semi-permeable membrane, then both the solutions are of same height. One is of glucose, other one is urea. Then what will happen? Okay. Remember, through the through the semipermembrane, water molecule can go inside and come outside. Okay. Now this concept is associated with the osmosis and the osmotic pressure pi. Correct. Concentration of both the solutions is same. Therefore, pi osmotic pressure is same. When osmotic pressure is same, there is no net movement of water molecules or osmosis. Remember, there is no net movement of the molecules across the membrane. So answer is A. Remember, there is no change. Question number 10. A solution of urea, molar mass is given, boils at 100.18 degrees centigrade at atmospheric pressure. Okay. Kf and Kb for water are given respectively. The above solution will freeze at, we have to find out the freezing temperature. This is the boiling temperature. We have to calculate the freezing temperature of that solution. So this is the colligative property. So there are two colligative properties given. One is the elevation, the boiling point, other one the depression, the freezing point. Correct? Now, so what is the change in the boiling point? Elevation, the boiling point, increase the boiling point. Boiling point of water is equal to 100 degrees centigrade. Correct? And now it is increased to 100.18, this solution, pure water and the solution. So difference is how much? 0.18 degrees centigrade. Okay. We cannot calculate delta TF because the freezing point is not known. Right? You can use the formula delta TB is equal to KB into molality. Delta TF is equal to KF into molality. We can calculate delta TF, and you know that freezing point of pure water is equal to 0 degrees centigrade. We can find out the freezing point of the solution after this. So what you can do is 1 divided by the other, this equation. Okay. Solutions are same. Molarity is same. Delta TB, difference is 0.18 divided by delta TF will have to calculate. Is equal to KB has been given in the question. KB is equal to 0.512. 0.512. Correct? Divided by KF is equal to KF is equal to 1.86. Okay. So when you calculate this delta TF is equal to 0.653 degree centigrade Kelvin scale. Correct? Now, freezing point of pure water is 0 degree centigrade. Correct? This is a depression, the freezing point. The depression is equal to delta TF. The delta TF is equal to 0.653. Okay? During depression of the freezing point is less than 0 degree. That means it is going towards minus 0.653 Kelvin. Should be less than 0 degree. But difference is 0.653, positive number. So what is the answer? Answer is equal to which one, students? B should be the answer. Correct? B. Is that clear? Thank you for watching. Have a nice day.